Hello everybody, this is Daniel bringing you guys another walkthrough of a packet tracer lab. In this episode, we will be going over designing and implementing a VLSM addressing scheme. So let's go ahead and get started. So right off the bat, we're going to need to determine the number of subnets needed. So let me go ahead and pull up Notepad here. We know that router 114 LAN is going to require 27 host IP addresses. So room 114 requires 27 usable host addresses. Room 279 requires 25 usable host addresses. Room 312 requires 14 usable host addresses. And finally, room 407 requires 8 usable host addresses. Alright, so our next step, determining how many subnets are needed in a network topology. So, looking at this, we can see that this 27 is way out of place. Thank you so a lot, Cisco. But we have 1, 2, 2, 2, oh my gosh, 2, 3, and 4 networks, plus an additional 5th between these two routers. So let's go ahead and put that down. Okay, so next step, determining the subnet masks for each one of these networks. So let's go ahead and start with room 114, 27 usable host addresses. So the formula for calculating usable host addresses is 2 to the power of the number of zeros, or the host bits, and that will minus 2, and that will equal the usable host addresses. So what number will we have to plug in order to get just above 27? Remember, we can't put, for instance, 2 to the power of 4 minus 2, because that would only be 14. And 14 is below 27, so we can't do that. However, if we did 5, then that would be 32, not 21, 32 minus 2, which is 30, and that would fulfill our requirements for room 114. So our subnet mask in binary would be 3 octets of all ones, and then 1110000. And how can I tell this? Well, remember, we already determined that there needed to be 5 host bits in a subnet mask, and those host bits are represented by zeros here. So this would be 128 plus 64 plus 32, which would equal 224 if my memory serves me correctly. Yeah, it seems about right. So the subnet mask would be /27. Remember, we already have 3 octets of all ones. 8 times 3 is 24, plus another 3 is 27. That would be 255.255.255.224. So moving on to room 279, 25 usable host addresses. Going back to our formula, 2 to the power of host bits minus 2 equals usable host addresses. 2 to the power of, once again, 5 minus 2 equals 32 minus 2 equals 30. So this would play out exactly the same way as this one did. It would be a /27 subnet mask and a 255.255.255.224 address. So going to the third one, going back to our formula once more, 2 to the power of host bits minus 2, and 2 to the power of 4 minus 2 is 16 minus 2, which is 14. So that would be 4 ones and 4 zeros, which is equal to 240. So 255.255.255.240, or /28. And as for second to last one, room 402, 8 usable host addresses. Unfortunately, I know what you guys might be thinking, oh, it's going to be 3, right? But unfortunately, as I said before, if we plug this in, as we plug 3 in, and I don't put -2 twice, that would only be 6 usable host addresses, which is not going to fulfill the requirements of 8 usable host addresses. So if instead we plug into 4, we will get 14 usable host addresses, and that will satisfy our requirements. Once again, this is going to be a /28 subnet mask, and it's 225.225, 255.255.255.240 address. And lastly, our serial connection. This one is just going to be 2 to the power 6 minus 2, which is, 2 to the power 2 minus 2. I was thinking of the other way around. 4 minus 2, 2 usable host addresses, which is all we need, because keep in mind that we only have branch 1 and branch 2 here. That's 2 IPs in total, so we only need 2 addresses. That would be a /30 and a 255.255.255.252. Keep in mind that once you go past /30, you really can't have networks anymore, because if we go to /31, which would have 1 usable host bit, there's going to be 0 usable host addresses. And why is this? Well, you have to keep in mind that the first address in any network is going to be the network. It's going to be the network address. This is used for DHCP purposes, so obviously you can't really mess around with it. And the last one is going to be the broadcast address. What this is going to do is allow a router to send a packet with the broadcast address, and gets flooded to all devices on that network. And then the device that needed the packet will reply back to the router with whatever it needs to. So those two addresses are stuff you can't mess around with, and that's why you usually can't have anything past /30. Alright, but enough of that. Now we get to dive into the real fun stuff, dividing the network. So we got ourselves a /24 network here. We're going to need 2 /27s, 2 /27s, I think. Yes. Oh, no, sorry, 2 /28s. Oh, okay, it's up here. Okay, yeah, 2 /27s, 2 /28s. I confused myself there. Okay, so what you want to do here? Oops. Is make sure you divide it into 2 halves, and you increase the subnet mask by 1. Because every time you increase the subnet mask by 1, the overall host addresses decrease by 1/2, which is why we're able to do this. I guess for clarity, I'll just write an arrow. Alright, and we're going to continue on with the lowest available network. Alright, so we got ourselves 2 26s. We need to pay attention once we hit the 27 mark. So /27 72.31.103.32/27, and I screwed this up. What is this doing? Alright. Okay, so we can see that we took 1/2. We have the network here, and then we have the network into 2 more halves here. Keep in mind this would not be 128, because we're already using this 128 network, so we have to split it between 0 and 128. Then we're dividing this network between 0 and 64, so it would have to be between 0 and 32. So that's why we have these networks here. And these two networks are going to be our room 114 LAN and our room 279 subnet masks and network addresses. Alright, I'll just go ahead and pull up an Excel. Open up a blank workbook. Subnet description. Pull this out. Number of hosts needed. Pull this out. Network address. First usable host address. And finally, our broadcast address. Alright, so our first subnet is going to be room 114, then room 279, then room 312, then room 407, and finally your serial link. As for number of hosts needed, it's pretty simple. It's right there, 27, 25, 14, and 8. So a network address for room 114 is going to be, as we calculated here, 172.31.103.0. So let's go ahead and put it there. The first usable host address is going to be 172.31.103.1. In a broadcast address, this is not the last usable host address. This is going to be the absolute last one. It's going to be 172.31.103.31. And how can I tell this? Well, we already know our next network is going to be starting with a .32. And we already know that broadcast address is the last IP of network. So by subtracting just one from this, we can get the broadcast address. Alright, so the second network address is going to be 192.1.31.103.32. First usable 172.31.103.33. And a broadcast 1 less than 64. 172.31.103.64. 63. Sorry. Alright, moving on. Or room 312 network. So since we need 2/28, we are going to continue with this because it's the next lowest network. So 172.31.103.64/26 will become 172.31.103.64/27 plus, not arrow, 172.31.103.96/27. Continue on with this network. 172.31.103.64/27 would equal 172.31.103.3216.80/28 and 172.31.103. Sorry, this is 64. Miscalculated. 64 and 80/27. 8, I mean. Okay. Once again, all we're doing is just halving. Obviously, I made some mistakes halving, but what you guys are going to want to look out for is the difference between this and this to be equal to the difference between this and this. Otherwise, you probably made a mistake, because keep in mind, all we're doing is just dividing halves. There's not really much else we're doing here. Okay, so network address 172.31.103.64. The broadcast address, the first usable host address of 172.31.103.65, and broadcast address of 172.31.103.79. And second to last network address 172.31.103.80. First usable, one more than that. And our broadcast address is going to be 95. And finally, for serial link, we are going to go back to this network, and we're going to subnet it so that it becomes a /30 network. Plus 172.31.103. 96, 128, 32, 16, 112/28. 172.31.103.96/28 becomes 2/29s. 96/29 plus 112 minus 96, 16, 8, 104/29. And finally, subnetting is now complete. Just have to write this one out. Okay, so we got our final network here. Let's go ahead and put that down. We're hosting it to network address 172.31.103.96. First usable, one more. Broadcast address 172.31.103.99. Okay, now that all that tedious stuff is done, now we get to actually assign all this stuff. Except we only have to do it for part of it. Just saying this ahead of time, you want to make sure you read this before you do this, otherwise you will probably not get the points. And how you know you get your points is by looking at this completion down here. It tells you the total amount of points you got from doing any given command. So move this over here. Okay, so going for branch 1 interfaces. Oh my gosh. I had to mess up. Okay. So one cool thing you can do with Packet Tracer, hover your mouse over these links and it'll tell you the interfaces that are connected. And actually, while we're waiting for that, let's go ahead and just do the switch and the PC first. So which ones do we have to do? Room 312. Okay. So go to inflan 1 because that's usually where you will put the IP address for a switch. This is 312, so using the second, I believe the second usable IP address. we'll type in the command IP address 172.31.103.66 and then subnet mask, which is 312. 255.255.255.240. Okay, let's check back and see if that router is done. Yes, there it goes. Branch 1 is gig 0 and gig 01. Okay, so interface G00. This is connected to room 114. So IP address 172.31.103.1 with the subnet mask of 255.255.255.224. We're gonna go ahead and no shut this interface. And I'll do it for this one. Next one, IP address 172.31. Oops, wrong window. Dot. Dot. 34. 103.34, 255.255.255.224. No shut. Okay, we're done with this one. Alright. And let's go ahead and make sure that everything is configured correctly. Yes. Okay, and finally going to PCD, we're going to go to IP configuration, and we're going to assign it the last usable IP address. So this is in a D network, which means that the broadcast would be .95, so 172.31.103.78, and instead of that we're going to use a 255.255.255.240. The default gateway is going to be 172.31.103.65. I believe. What did I miss? What did I miss? Ooh. Okay, so let's go back and correct our mistakes. Apparently got the IP address wrong, so let's go back and look at that. So going back in G01. Pull up my Excel table. Oh gosh. Ugh, one off, guys, one off. 1.33. Okay. And then we forgot to no shut this and put an default gateway. Which is .65. And finally, we really messed up here somehow. Let's go look at that again. PCD. Ah, that's my mistake. Dang. Just making these mistakes. 94 and 80. 1. Yep, and that is our full score. Alright, so we're finally done with this Packet Tracer Lab. So if you like this video, definitely consider liking. If you want more, definitely consider subscribing. If you have any questions, definitely feel free to post in the comments below. But once again, guys, I am Daniel, and I will see you guys in the next video.